Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 11.1.3, which is Ratios of Similarity. And so the point of this chapter is to get you used to noticing the differences between questions when they talk about ratios of similarity when it comes to area or surface area, and ratios of similarity when it comes to volume and the ratios of similarity when it comes to linear. So before we begin this Benjamin Franklin problem here, let's just talk about the linear scale factor. If the linear scale factor was r, that means that the area scale factor would be r squared, and then the volume scale factor would be r cubed. Hopefully you remember that from the last lesson. And so we just have to be able to discern which one they're asking us to do. In 11-27, it says, to honor Benjamin Franklin, designers will place a statue of him outside the Liberty Bell exhibit hall in Philadelphia. The designers decided to place a similar version on a table inside the building. The dimensions of the life-size statue will be 4 times the smaller statue. So automatically off the cuff, what I'm reading is that the linear scale factor of the figure is 4, right? 4 times, every dimension will be 4 times larger. Planners expect to need 1.5 pints of paint to coat the small statue. Notice how the word coat shows up in here. When I see the word coat the statue, that talks to me about surface area. So I'm leaning more towards area scale factor when it comes to the 1.5 pints of paint. And then they also know that the small statue will weigh 14 pounds. So all the material that it takes to construct the statue, not just the outside, but the inside also, this whole 14 pounds here, this communicates volume scale factor to me, or volume. So hopefully you're seeing how I'm extrapolating information from each of these pieces in this word problem here. So it says how many gallons of paint are needed to paint the life-size statue. So again, I'm seeing this as an area scale factor problem. And another thing, and it's not exactly the point of the problem, but they do want this in gallons. So we do need to know that there are 8 pints of paint per gallon. That's the ratio of that. So whatever we get, we'll have to end up dividing it by 8 because our paint is given in pints. So in A, well, remember, we need 1.5 gallons of paint for the small, and the scale factor for the linear is 4, but because we're talking about area, right? We're talking about all the paint it takes to surround the painting. I'm going to make that 1.5 times 4 squared. So whatever 16 times 1.5 is, I believe that's going to be 24 pints. And again, we're going to divide that by 8. So 24 divided by 8 will give me 3 gallons, and it'll take 3 gallons of paint to cover the statue. And then if it says if the small statue is made of the same material as the large statue, how much will the life-size statue weigh? Well, remember, the small statue is 14 pounds. And again, the linear scale factor is 4. We're talking about all the stuff it takes to fill the inside and outside. So that's going to be 4 cubed. We're talking volume here. And so 64 times 14 is going to be 896 pounds. So notice how that's not pounds cubed, right? Because we're talking about the weight of it. But if they were to ask us the construction material, it would take the inside, or let's say they were filling it with water for some reason, or filling it with some type of thing, that would be a dimension cubed. So this will just be 896 pounds. All right, I will be right back with the next problem. In problem 11-28, it talks about the Blackbird Oil Company considering the purchase of 20 new oil tanks, and they can buy the jumbo or standard model storage tank. Each standard model holds 12,000 gallons. The dimensions are 4/5 the size of a similarly shaped jumbo model, and we have to figure out how much storage capacity does 20 jumbo models give over the standard model. Well, a couple different ways you can handle this. You could, first off, say that you don't know how much the jumbo model is. You could just call that X. And if you scale factored it down, right? If you scale factored it down, you would get the 12,000. Here's the thing, though, is that the dimensions are 4/5 the size of the jumbo model, but we're talking about gallon storage capacity here. So that means that 4/5 would need to be cubed. So this is solving for the jumbo. right? So you could say x times 64 over 125 equals 12,000. So by multiplying 125 over 64 on either side, you would cancel those out, and you'd end up with x equals 12,000 times 125 divided by 64, and you end up with 23437.50 gallons. And that is how much the jumbo model will hold. Now, the other way you could have handled it is you could have actually just flipped your ratio, right? Because 4/5 is shrinking the model, right? That's going from large down to small. You could have flipped it and called it 5/4. 5/4, and then that would go from small to large. That is what's making the model larger, right? And then you could have just taken 12,000 times 5/4 cubed, which actually is this part of the equation right here. Either way, you end up with the 23,437.5 gallons. So now it says it actually asks how much storage capacity would 20 jumbo models have over the standard models. So this is one of the jumbo models. So I'm going to take this and multiply it by 20. And I'm going to get 468,750. And then I'm going to subtract 12 times 20, 12,000 times 20. So that's going to be 240,000 gallons here. So I'm going to do 4678750 minus that previous answer. And what I end up getting is 228,750. So almost double the amount, right? 20 of those jumbo models will hold almost double what the standards will hold, and that delves right into part B here, and I didn't realize that until part B. I apologize for that. If the jumbo tanks cost 50% more than the standard tanks, which tank is a better buy? So actually, it's the jumbo model, right? The jumbo is better because you are paying only 50% more for almost double the carrying capacity. That's parts A and B. Let's see here. I guess I'll move to the right a little bit for part C here. Part C is asking us if 1 cubic foot is approximately 7.48 gallons, what is the volume of the standard storage tank in cubic feet? So in part C, I'm going to start off with my 12,000, and I'm actually going to write in the the units here. Now I'm going to be doing a measurement conversion here. So I'm trying to eliminate gallons and trying to keep things in cubic feet, which means I'm going to put gallons on bottom because I want the gallons to cancel each other out. And I know that 7.48 gallons is approximately 1 cubic foot. So at this point, the gallons are going to cancel each other out, and I end up with 12,000 over 7.48, and that's going to be in cubic feet. So I just have to do 12,000 divided by 7.48, and I end up with 1604.278 cubic feet. All right. Let's take a look at D here. In D, it says 1 meter is approximately 3.28 feet. How many cubic meters of oil will the standard storage tank hold? Well, in this case, it's a little bit weird because they're talking about 1 meter being feet. And then they ask us to do cubic meters of oil here. So that's going to be a little bit weird. So we know that one of these storage tanks holds 1604.278 feet cubed. The problem is they only give us measures in linear units here. So what we want to know cubic meters. So what I'm going to do is I know that the feet cubed have to be on bottom, and that's going to be and I know that it's going to have to be meters cubed up top. The problem is they only give this to me in feet. So how do I do this conversion while doing a linear to cubic to a volume conversion at the end of the day? Well, I know that 1 meter is approximately 3.28 feet. But again, the feet cubed and the feet aren't going to cancel each other out yet until I cube everything. So that's going to be 1604.278 feet cubed times 1 meter cubed over 3.28 to the third power. And that's going to be 35.287 feet cubed. So now the feet cubed can cancel each other out. And if I just do 1604.278 over 35.287, so I'll do that. So I'll do 1604.278 divided by my previous answer, and I will end up with 45.463 meters cubed. 45.463 meters cubed. So a lot of conversion going on here. Now that last one was a bit odd. They ask us in part E, what was different about the calculation in part D to part C? How does it relate to scale factors for similar solids? Well, the difference is that we actually had to cube one of them because it was given to us in a linear scale factor. So I'll write that down. Go down here. Part C was given already in volume scale factor, in volume or in cubic units. So no cubing was necessary. Part D was given in linear units. So we had to cube them before converting. All right, that will handle 11-28. I'll be back with the next problem. So in 11-129, we're talking about Rosalind trying to order wood chips to cover her dog park area. And so it says the size of the dog park is 9.5 feet by 12 feet, and she wants the wood chips to be 4 inches deep. So we're looking at a volumetric dimension here with some unit conversion because we've got feet to inches. It says wood chips are sold by the cubic yard, so I'm looking at another unit conversion here, and it says initially she calculates she would need to order 12 cubic yards of wood chips, but it turns out that's too many because an entire dump truck would have to deliver those wood chips, which obviously is not what she wants. So let's see what her error was. So let's go and just find out the dimensions of her dog park in volumetric units here. So what I've got is I'm going to do 9.5 by 12. That's going to give me the surface area of the dog park, and then we'll multiply it by the inches deep here. So 9.5 times 12 is going to be 144 feet squared. Now to get that third dimension, it's going to be 4 inches deep. Well, if I wanted to convert inches into feet, I would do 4 inches, right, times, looks like 12 inches per 1 foot. So I'm looking at 1/3 of a foot for my depth of this dog run. So I'm going to multiply that by 1/3 foot, which would then give us 144 divided by 3, which is going to be 38 feet cubed. So that's going to be the amount of wood chips she's going to need in cubic feet in order to fill this dog park. Here's the problem, is that the wood chips are sold by the cubic yard. And so what we have to do is we have to convert this 38 cubic feet into cubic yards. Well, how do I do that? Well, I know that it's going to be 38 feet cubed, and I'm going to need to multiply that by feet on bottom and yards up top. And I know that 1 yard is equal to 3 feet. Here's the problem, is that upon my conversion, if I try to cancel the feet out, they don't cancel out completely. I end up with feet squared yards, which doesn't make any sense. So what I need to do is I need to cube everything here to make sure that the volumes are canceling with the volumes and that the volumes aren't canceling with linear dimensions. So I've got 38 feet cubed times 1 cubic yard over 27 feet cubed. And I believe this is probably where Rosalina's error happened. And so you end up with 38 divided by 27. Or Rosaline. That's Super Mario Brothers right there I was thinking about. 1.407 looks like cubic yards. is going to be how many cubic yards Rosalane should order for her dog park, or if you want to keep it in the vein of Super Mario Brothers, Rosalina would have to order for her Yoshi Run park. So that should wrap it up for this particular section. Again, the point of this is to make sure we understand a few things. Unit conversion, knowing the difference between surface area scale factor and volume scale factor, and knowing how to manipulate from linear scale factor into each one. So that should wrap it up for this one. As always, leave comments or questions in the comments area, and I will see you all in the next episode.